Alright, tm55202, Operational Maintenance, Diesel Electric Locomotive, Chapter 16, Locomotive Application 152, Application Problem, Selection of the proper type of the size of the locomotive, particular operation, group operation that requires detailed study of many variable factors involved with the train movement. These factors are briefly described here, and then general information, thorough understanding of them may be needed to experience the personnel responsible for the related discussion, decisions, or maybe delay the calculation, experience, transportation men are required to determine the power requirements made, the tonnage, rating, the specific amount of power in any operation, any army operation where the capacity to move the schedule operation routine, the uncertain, ungoverned, and expectancy approximately the rating may be temporarily shorter than however the heavy tonnage which would be locomotive beyond is a short time rating to be avoided, making the trainings operating the trains for the frequently equipment the requirements cutting out any en route part of the locomotive power equipment sufficient and factors affecting the application problem discussed in the separate in the paragraphs 155 through 159. Some factors normally uniform in the United States must necessarily be included in the study of the universal application. 153. The track. The gauges and the proper matching of the wheels spacing of the truck gauges should not be overlooked. In foreign countries, many of the different track gauges exist. Multiple track gauges are provided with the situation change of the locomotive required. The time shop and the facilities multiple gauge locomotives depicted in Figure 97. Weight of the rails, allowable axle and loading of the varies the weight of the rail, the speed of operation, other factors of the rails, the weighting of the 60 pound per yard less wall. Wheels handle about 500 pounds of the axle load. 2 wheels per pound of the rear wheel weight. This is about 30,000 pounds of axle loading of the 60 pound rail. 25,000 pound loading of the 50 pound rail. As rail becomes heavier, allowable the axle leading increasingly approximately value of 700 pounds per rail per 90 pound rail. That is 63,000 pounds. Condition the spacing the time of the type of the bell, standard maintenance, general condition of the tie plates, rail plate, rail joints, other items affecting the rail shipment are factors considering the application of engineering locomotive application. 154. Operating limits. The bridges and the standard operation practices that are not known to the information should obtain to the Corps Engineering reconnaissance. Other reliable sources concerning the elimination of the capacity, speed of which the train is safely operated with the bridges, oversee the areas, considerable reinforcement strength, any of the bridges, the number that required for the heavier the Army locomotives and can be used. B. Clearance of the overall height of the width of the locomotive overhang of the covers. They should be determined within any cause above the tunnel and fixed. Any questions about the tunnel or fixed structures constituting obstruction of the movement of the trains. The U.S. built motive power rolling stock will generally require wider clearances that found overseas areas. Curvatures covered with the tracks more the resistant train of the movement straight of the track. Resistance increase with the degree of the curvature must be taken into consideration, studying the power of the requirements of sharp curves. Sharp curves may also cause derailment and damage to the coupler. If and warned of the type of locomotive is dispatched, a 1 degree of each 100 feet of the track is 136 degree of the complete circle. The curve of the resistance verifies the truck of the banking of the track, etc. A valve with 1 pound per ton the train weight per degree of the curvature is used in calculating training movement. The speed limitation conditions of traffic is imposed. The speed limitation below the maximum capabilities of the locomotive. The characteristic of the load, the variation affecting the study of the movement of the power. For example, the speed limit approaching the upgrade will, due to the sharp curve, will create a load of the locomotive on the grade for the difference. A considerable load for the same of the train corresponding to the grade of the approach for the higher speed. The speed limitation applied with any portion of the train is restricted zone, even though the locomotive has reached the straight and unrestricted section track. Type of couplers. Couplers in the United States are standard AAR type 34 and a 1/2 inch side, and the springs in the draft gear that absorb some of the shocks and swing enough to permit the free movement around the curve of the couplers. In most of the foreign countries, the greatly for the American couplers, locomotives must have the couplers conform to the rolling stock utilized. The U.S. Army Foreign Services diesel electric locomotives are designed with the Wilson 41 inch couplers. Height. Type of the brakes. The vacuum brake system are used in the foreign country. The proper exhaust of the brake application valve must be the locomotive equipment, and as such, compressed air systems are described in paragraph 119. The 155. The profile gives the evaluation of the track of all points from which can be obtained by the raise of the fall, and the points of the proposed portion of the track have been consistent with the general trend of the rise of the fall and are grouped in analysis and slope and any section of the compressor with the percentage greater than traffic movement upgraded naturally requires an extra power that must be considered by determining the locomotive application of the grade with the limit of the size of the training that can be moved to the given locomotive is called the ruling grade of the section division. The actual grade of the rate of the uniform, the rise of the fall of the traction is calculated with dividing the difference with the elevation of the 2 points, and the distance between the point is expressed in the percentage of the 2% means the difference between 2 feet of elevation and a 100-foot track length. If this actual grade is verified slightly adjacent section, the average grade of all the section must be studying train movement. The selection of the points must be an average grade of the suitable for the use of train recalculation and matter of judgment experience. Grade resistance is calculated at 20 pounds per ton on each of the grade. A ton of 2,000 pounds must be raised 1 foot for 100 foot traveled over 1% grade. The grade of the 2% of the train is raised 2 feet, and the grade of resistance of 40 pounds per ton. The grade of the 50%. 0.50% of the train was raised 1/2 of the foot of the grade of resistance of the 10% per ton. On the ground, the gravity helps move the train. Corresponding negative forces of the calculation with the negative downgrade resistance balances the outer force retarding the train. It will coast in constant speed without the power, without negative downgrade resistance exceeding the other forces retarding the train. It will coast increasing the speed that requires the application of the brakes at maximum allowable speed. Reach. 156, the type of the service. There are 3 types of service: railway train services, passenger service, freight, and switching. Passenger service ambulance trains may require steam generator, locomotive train heating, a higher degree of the ratio. Preferable passenger service brake system should have been rotary and adjusting braking power. In the type of the length of the train, a light switching services, train conditions require light locomotive, low gear with the starting track and independent braking applications are often sufficient in few cases of being moved. It is practicable to connect the air hose. Long trains should not be stopped with the independent brake. The road freight, and generally equipped with designed intermediate stops, helper services, humping services, special application of above the group of services, structural changes required, instrumentation in operation, several cold temperature territory infiltrated during operation, extremely dusty surrounding mines and mills and desert operations. The main basic similarities between different design permits and interchangeable locomotives. When the locomotive is assigned to different services, it must be operated under the restrictions described elsewhere in the manual, or it must be modified in the gearing, bracing, and etc. is in shop. Train resistance. The train resistance, some of the force opposed to the motion of the train at the constant speed of the level of the track, still in the air, made of the rolling friction and the general friction and normal air resistance. Many of the formulas have been devised. The calculated resistance valves of different types of the train. Resistance valves varies from the speed of the train, the type of the bearings, the axle loading, extremely cold, whether increase of the general friction, and the Davis formulas are mostly widely used and can be found in numerous railroad textbooks. However, the entire family curve derived from the formula narrows down the approximate value of 5 pounds per ton of the train weight for the speed of below 30 miles per hour. Above 30 miles per hour, the resistance will vary from 6 to 12, and even more pounds per ton. The train weight of the significant factors shall be with the given locomotive obtained the given train. These factors studied in the detailed regular road operation, where the cost of competitive schedules is important to the elementary analyst of the point. Paragraph 185, the observation and the experience with to serve the most of the requirements of the Army. The power required for the accelerate the rate of 1 mile per hour. The second is about 100 pounds per ton. The freight of the 100 pounds per ton freight train may usually accelerate at about 1/10 to 2% per mile per second. The power requirement of 10 pounds or 20 pounds per train is responsible valve. Accelerating rate of the confusion of the passenger trains increase in the speed of the standstill is 20 miles per hour. The 20-second increase in the speed 1 mile per hour during each second of time. 30 seconds it will travel 30 miles per hour. If the freight train requires 80 seconds to reach 20 miles per hour, to accelerate to 1/4 miles per hour. The second essential is express the acceleration to change the speed of the even its fast second fast speed of the per second per second of the miles per second. The adhesion and coefficient of the friction between the driving wheels and the rails determine the maximum traction effort exerted by the slipping of the wheels of the two surfaces pressed together requires the slide of one of the another. The usual definite relationship between the sliding force required of pressing the forces existing between the two forces. The ratio of sliding over the pressing force of the called the coefficient friction. Adversing adhesion. The various tests have been determined that coefficient friction between the train wheels and steel rails, force pressing together with the weight of the point of the contact, consistent with the test of the wide and the long period of the years. wide variety of electrical locomotives over the long period of years show starting the adhesive values varying 48% downward. If it had been found a clean, dry rail, the factor of 30% is usually obtainable to start, and a factor of 20% to 25% is normal at a wet rail. If the sand is used, however, the train speed rises. Various factors intended to reduce the weight on the driver's mount entirely, thereby all drive wheels are slipped. Maximum use of full adhesive fuel value decrease of the train speed. Train movements require power to overcome the grade resistance, paragraph 155, and the grade resistance of 154. Train resistance, paragraph 157. The power required in accelerating the train standstill for immediate slowdowns after the determined to decide the train started the running of the grade given the locomotive. It must be established whether the locomotive will be traveling at the speed continuous of the loading rate of those short time running ratings and has been used available overload capacity necessary to know whether the other grades got encountered with the type of the spend of the grades in detail. The study with the speed time distance the calculator is required to complete calculations very involved. Table 2 shows the typical selected entry of the calculation. The purpose here to be in conveying with the idea the relevant importance of resistance, curve resistance, train resistance, acceleration of the various speeds, and the time spent the distance transverse to each stop is not shown. The values that are shown in the given speed of the implied the time distance calculations must apply from one speed from another speed. Various stops must be assumed the intervals sufficient close to the various tractive effort resistance values approximately constant during the step. The significant facts are shown in table 2. The traction effort of the locomotive decreases the speed increase that is shown in the locomotive traction effort column 3. The train resistance increases in the speed increase in column 6. The net traction effort for the acceleration of the grade and the low speed of the column 8. The traction reaches the balancing constant speed of the line 3 with available traction effort is used to overcome the various resistance of the train movement. The train resistance is greater than the percentage of the total speed increase of the line 3B and greater. Assumed the change of the 0.3% to 15% traction effort of the 5175 becomes available to further acceleration. The average rate of the acceleration is shown to be 0.14 miles per second. In line the balance speed again with reach of the new condition over level track of the straight track of the higher balance of the speed would be reached and a subsequent increase the grade of the curvature would be reduced for the train speed and is being train movement the constant adjustment of the balance between the continual varying forces the speed times the distance calculation. Steam locomotives largely studied with the scheduled performance and assurance that against the stalling of the heavy grades of the study of the diesel electric locomotive takes an additional significant respect for the extent of the duration overloads is necessary for the locomotive application test operation. Most satisfactory results regulations obtained with the basic factors and engineering calculation are understood. The additional columns of the table 2 the average acceleration between the two lines and time spent acceleration between the selected speed values. The column 2 the distance of the traverse and the intervals. The figures accurately occupy intermediately in between lines of the calculation. If the tables are seen with all the entries straight line and for the sake of the convenience and analysis the nevertheless understood the ability to the respective blocks and just as described. Here's table 2 the table data of the speed time data in the calculations of 1,735 tons. Shows the speeds miles per hour and traction effort of the grade resistance, the grade resistance curve in the train, the total traction effort of acceleration rate of acceleration miles per hour. Part 6 Inspection and Maintenance, Chapter 17 Regulations governing inspection and testing.